Hello, this is Dan Alford with ARC Specialties. We like blurring the line between robots and teleoperated devices. Recently we were at a conference and I met Lorraine with Haption, and she has an interesting machine that's going to help us do some of the new applications that we're working on. You guys describe what you guys are working on.
Okay, hi, Lorraine Amitrano with Haption. What we have is a telerobotic device that works in force feedback. So we can control multiple robots, and we're controlling them with force feedback, so any forces on the robot you'll feel back here in the controller. And what that does for you is, instead of just seeing what the robot is doing, you can feel what's happening on this end, which makes it much easier for the operator to do the application they're trying to do. We can also operate very large robots with very little force over here, so a person can be doing a very heavy procedure with very light movement on this end. And we feel the force feedback from the robot on the other end, no matter what the application is.
And you're able to scale that feedback, so it could be a fraction or a multiple of the actual weight that you're dealing with.
Correct. So depending on your application, you may have a very large robot or a very small robot. You may be working with a small item or a large heavy item. So everything can be just moved within the software. Whether it's force feedback, you can have a force going higher or lower. You can adjust that, or you can also have the movement going factor changed as well.
So a small movement on your part could create a large one, or vice versa.
A much larger movement, depending, again, the size of the robot, what you're working with, what your application is. You can change the force and movement factors.
So Zach, what'd you hook it up to today?
Yeah, so right now we have it hooked up to a KUKA robot. And so if you've seen any of our previous videos, we've teleoperated robots before. Our last one being a KUKA robot with some joysticks. And that's all great, that's a lot of fun. You know, it brought out the inner child in me, but having actual force feedback takes it to the next level. Being able to tell whenever you're pushing against an object really gives, a simulation of the human touch, which, for certain applications is necessary.
So that's what the trash can is.
Yes, in this case, that's what the trash can is. It's something that's a little compliant that we can really push against and gives you direct feedback at the actual control station.
So you can feel that right now?
Yes, I can. So I'm pressing down on that rubber trash can, and I can feel that stop over here as I press on it. And the harder I press on it, the more force I can feel over here. So any forces that are happening on the robot over here, I can feel it here as it happens.
And it's not just on J6, the last axis. You can feel feedback any place on the robot.
Correct.
So if you're bumping with an elbow, you know it.
Correct. So you can set stops within the software. If you don't want the robot to go beyond a certain place, you can set limits on the angles of the joints. And you can feel that force no matter what you're touching.
Very cool. So we're talking about remote handling of dangerous items. We're talking about sanding, grinding. What other applications? We're trying to...
They're used in a lot of research applications, but in the real world, a lot of nuclear applications. Anywhere where you have a dangerous, whether it's a material or a dangerous operation, and you want to get the person out of danger, you still have your skilled operator, but now they're removed from that danger, whether it's sparks or chemicals or nuclear waste or things of that matter.
And you're with us, the same approach. Industrial robots are now commodity, so that's a relatively cheap 6-axis manipulator.
Correct.
Very cool. So if anybody in the audience has any applications such as we've described here, give us a call. We want to work with these people and develop some interesting new teleoperated and autonomous combination robot systems. We appreciate all your help. Thanks for coming.
Thank you. Very happy to be here.
ARC Specialties thrives on problems.
Send us yours.